Okay, so let's talk about the reactions that are occurring at each electrode. Say, so now that you know what are ionic half equations, so basically we can break down the reactions occurring at each electrode into half equations, right? So for example, if we have a solution of copper chloride, okay, copper 2 chloride specifically. So add, if you have a molten solution of copper 2 chloride, let's say, so add the anode, which is the positively charged electrode, will have oxidation, right? So at the anode, we'll have chlorine losing two electrons and just turning into chlorine gas, right? So we have chloride ions, right? And lose two electrons and then they turn into chlorine gas, right? So you'll be seeing bubbles at the anode, okay? Bubbles arising at the anode, okay? And that's just showing you, okay, there is actually chlorine gas forming at the anode. On the other hand, we'll have copper, and copper 2 will be reduced to copper metal. So, yeah, and you'll see that at the negatively charged electrode or the cathode, you'll have the deposition of copper. Okay, you'll have like a plating of copper on top of the electrode, right? So you'll be seeing like a brassy colored or a golden brown metal depositing on the cathode, and that is actually the solid copper depositing. So the rules at the electrodes you should know about. So let's just talk about the rules at the electrode. So firstly, we'll talk about the rules at the anode. So oxygen will be produced unless the ionic compounds contain halide ions. Okay. So for example, most of the time you will be dealing with solutions containing aqueous solutions of ionic compounds. Okay. Mostly you'll be dealing with aqueous solutions of ionic compounds. And what are aqueous solutions? They're basically ionic compounds dissolved in water. Okay. At your level, they're ionic compounds dissolved in water. So at the anode, you have to remember this rule. So yeah, these are very important rules. At the anode, say, for example, if you have a solution of sodium chloride again, right? Not sodium chloride. Let's just take another example. So, for example, we take another ionic compound. Um, let's take another ionic compound. So we have maybe lead sulfide. Okay, we have lead sulfide. So at the anode, we have an aqueous solution of lead sulfide. At the anode, what will happen is that oxygen will always be formed at the anode, okay, and that is because of the hydroxide ions in the water. So yeah, unless the ionic compound that is dissolved in water contains halide ions. So, yeah, so for example, if it contains a chloride, bromide, or iodide ion, so yeah, unless it contains the halide ions, the oxygen will always be formed at the anode, and that oxygen is arising from the hydroxide ions in the water. So yeah, if there are halide ions, the halogen will be produced instead, of course. So, yes, if you have an aqueous solution of sodium chloride, which you were going to discuss earlier, so if you have an aqueous solution of sodium chloride, let's take aqueous solution of sodium chloride. So obviously, sodium ions we have chloride ions. So the chloride ions will actually be discharged at the anode, and this will form the chlorine gas, right? Acha, why is oxygen formed on the anode? So you need to understand that, you know, the uh, water, okay, water जो है ना, it contains ions, ठीक है, it contains H plus ions, OH negative ions, सही है. अच्छा, अब इसमें ये होता है कि जो OH negative ions है ना, सही है, more they are less reactive as compared to all other ये वाले जो ions हैं, सही है, and that's why they give away this electron very easily. So yeah, they are more reactive as compared to these ions, the negatively charged ions, and that's why they give away this electron very easily. So most of the time, these OH ions are getting discharged at the anode, right? and that's why oxygen and gas is being produced. So yeah, at your level, itna pata ho, it's okay. On the other hand, if you have the halide ions, okay, the chlorine, chloride, bromide, and iodide, so they are far more reactive as compared to the hydroxide ions, and they will, you know, overpower. They will not let hydroxide get discharged, okay, at the anode. So preferentially, because they are more reactive than the hydroxide ion, they will prefer getting discharged as compared to the hydroxide. So when you have an aqueous solution of sodium chloride, bubbles will arise at the anode, but those bubbles will not be the bubbles of oxygen. They will be the bubbles of chlorine gas, bromine gas, iodine, okay, whatever halide ion was present in the aqueous solution. Understood? अभी तक समझ आ गया?
जी।
Okay. Now let's talk about the rule at the cathode. Okay. So the rules at the cathode क्या होते हैं? So hydrogen from the H plus in water is produced unless the ions in the ionic compound are from a metal less reactive than hydrogen. Okay. If the metal is less reactive, it will be produced instead. So the metal has to be less reactive, right, in order for it to get discharged. So, when an ion gets, interacts with this electrode. So, for example, if a negative ion interacts with the anode, right, and it loses its electrons, okay, to the anode, this process is known as discharging, okay, because obviously this ion is losing its charge. So, इसको हम discharge कहते हैं कि ion is getting discharged, right? Similarly, at the cathode, the positively charged ions will gain electrons and they will get discharged. Okay? So at the cathode, preferentially hydrogen will get discharged and will turn into hydrogen gas. Unless, okay, this is an exception, unless the positive ions are from a metal that is less reactive than hydrogen. That is the rule for the cathode. So yeah. Okay. So यहाँ तक समझ आ गया?